good morning and good afternoon, guys. Thank you so much for joining this session on service mesh in the world of microservices. So before we jump into the session, I would like to give a brief intro about the speakers. So my name is Swaminathan Vetri. I work as an architect at Maersk, and I'm a Microsoft MVP under Developer Technologies. We also have three other MVPs joining us today. So first one is Elias. So he is an MVP under Azure, and he works for ABB. And we also have Karthikeyan, who is also another MVP under Azure Technologies. And we also have Augustine, who is an Microsoft MVP under Developer Technologies, right? So today we are going to talk about how in the world of microservices, the service mesh is going to be helpful and what kind of problems it is going to solve, right? So, but before we jump into the service mesh aspects of it, let's understand the basics of microservices and then what kind of challenges we get in terms of microservices, architecture, etc. Right? So traditionally, we've all been building a monolith application, right? Where a single application would be composed of multiple modules. It could be 10 or 20, or dependent on the volume of the application, right? And what we used to do is, irrespective of whichever module is having a change, we go and deploy the entire application to the production or at different environments. So that brings its own challenges, on typical challenges on the regression aspects of it, right? If there's a change in module A, and if you want to deploy that, you need to do the regression of the entire application to ensure everything is intact. And also imagine if this application is being built by multiple teams, then there's a huge amount of coordination and communication needed to come up with a proper release plan and follow the release cadence, etc. That definitely brings down the time to market, and which is not really a good thing, a good situation to be in. And that's one of the reasons people started moving towards microservices, right? With microservices, what would happen is, let's say if your application is having 10 different modules, you could typically make them into 10 different microservices if they fall under different bounded contexts, and then you can go and build, test, and deploy them independently of one another. So this brings a lot of flexibility, right? So you are bringing down your testing cycle. You can also hit the market with your feature enhancement in a much faster way. So that way, time to market is one of the key aspects in a business, right? So that's how everyone started moving from monolith to microservices. So imagine if you're migrating one application, maybe one application could bring you maybe 10 microservices. And if you migrate as 10 different applications, you can already imagine that we are getting 100 microservices, right? And as you and if you extrapolate it at an organization level, you could very well start getting into hundreds or thousands of microservices. If you're in such situation, how it brings on its own complexities, right? Some of the complexities could be, how do we monitor these entire microservices, right? So how do we understand which microservice is calling which is a microservice, or how do we know if there is a problem in the production? How do you go and troubleshoot the issue? And even we also have issues around, these are some of the core technical issues, right? And talking about the business side of it. So now that you have a flexibility to deploy individual components, the product owners would always want it to go as fast as possible to the production, right? I think we all have heard this term as, I wanted it yesterday. Nobody waits for tomorrow or for day after tomorrow, right? So in such cases, you need to ensure you are able to push your microservice into the production and then do a bit of testing with a limited set of users, and then you would want to enhance it for further global rollout or so. So those are some of the business problems which we would also start having as we build large scale microservices, right? So now what's the solution for this? This could be addressed in multiple ways, but one of the solutions could be by using a service mesh, where you could build an additional layer on top of your existing microservices architecture, and then you could offload some of these cross-cutting concerns of traffic management or the observability or the security aspects to it, and then that could take care of these aspects, and leaving the development team focusing more on their own functionality building, etc. All right, that's going to be the crux of this entire session. So we'll be hearing from the other experts on how on basically some of the high-level capabilities of service mesh, which are like traffic management, and then about the observability and about the security, etc. And we'll also try to see if there are any challenges in implementing service mesh on our existing workloads, right? So with that brief introduction, I would like to start with I would like to have Karthik start with the traffic management aspects of service mesh, with a bit of insights on other aspects too.
Yeah. Thanks, Swami. Thanks for the nice introduction of service mesh. Okay, so before trying to get into what is traffic management is, I would like to talk about what problem the traffic management of service mesh solves. It tries to solve two problems. The one is the technical problem, another is a business problem. What Swami was telling, everybody wants it yesterday, right? So the business problem is people wanted things to be in production as fast as possible, even if it's a bug fix or a feature or any other small enhancement we do, they want that to be in production as soon as possible. But that is not the case in real time, right? So you have to test it. You have to make sure the production does not goes down because of some small mistake or some small bug that has creeped in. So these are the things there is a challenge that exists. And then with respect to technical problem, it solves this. There is the current way things are moving forward is a polyglot, right? So polyglot meaning people wants to have more technology in their stack, meaning some workload needs Python, some workload needs Node.js, some workload needs .NET Core, some workload needs maybe Rust. So these are the polyglot technology that should be available in your production server, but we have solved the problem. So like how did you solve it? By using Docker, right? So you build once and deploy everywhere, or it works in every machine. So those are problems we solved. The problem with that problem is it has created one more problem, that is, if you want to do some cross-country concern, such as say, I want to do a TLS termination, I want to do some kind of authentication, I want to do some kind of say app monitoring, or set some logging mechanism. So these are the two problems that exist in the current system, where once you move to a bigger place like Kubernetes or Docker-based system, Polyglot, or you want things faster, the service mesh solves the problem. The first business problem it solves is it gives you something called a capability to do a A/B testing, canary rollouts, stage rollouts with percentage-based traffic splits. Okay, what is A/B testing and canary rollouts? A/B testing is nothing but split testing, where what we can do is you can actually send the same link or same page to different pages to same user, meaning to figure out which is actually making him buy more. For example, if it's some like e-commerce site, he can make sure that you can test it whether the color red is making him buy more, or green is making him buy more. So these are the A/B testing that can be done, that can be passed to the same customer. In case of canary rollouts, if there is a new feature or new bug or new thing that needs to be released to the customer, what we can do is we can send only 20% or 10% or 5% of the traffic to the same customer, and then the customer can actually start slowly roll out. When there is an issue with that release, you can actually roll back or increase the percentage of traffic splits. So that is the main thing that technical problem solves. How it solves is, now we have a huge power with us to actually test things in production, right? So it is not just we don't have to be like waiting for the testing team to test it for 10 days to make sure everything doesn't go down. We have the power to actually push it to production, do a little bit of testing, and then make sure that production is actually works better. There's something called like a stay in Facebook. They came up with something called fast fail, right? Fail faster, so that you can actually move with the business rather than the IT is trying to pull the business down, right? So that is the main business problem that solves. It solves in a very out of box layer. Okay, so what it does is, it is not few configurations you do, the A/B testing and canary rollouts, you can do it in within minutes. Okay, so that is the first thing. And the other service mesh, the capability it provides are circuit breakers, meaning it actually gives you more resilience to your application through circuit breakers, easy setting up timers and retries and timeouts. It also helps you in dynamic service discovery. Why is dynamic service discovery is needed is because, so we say I have like 100 microservices, as Swami was saying. So all the microservices, I need to put it somewhere, put it in a routing, and then I have to know where it is. I have to know how to talk to it. So these are the very great challenges that is faced right now. Service mesh actually solves that problem. It gives you a load balancing. It gives you TLS termination. It gives you proper health checks. It gives you fault injections. It gives you rich metrics. These are all out of the box, where you don't have to do much actually, not to change your Docker file or your application code. Without changing that, you will be able to see and do and get your business and technical problems solved, so that you can move faster in your business, also in your engineering aspects of things. So these are the main things I can see with respect to traffic management. The main thing I always see is A/B testing and canary rollout, which is like a huge thing, because people want things to be as fast as possible. The next main thing you can do is all the cross-cutting concern can be addressed without changing the code, which is another way of implementing multiple polyglot-based technology into your system. So that's the main aspects of service mesh, if you ask me, with respect to traffic management.
Great.
Back to you,
I think those are great inputs, Karthik. I think I think the major part of it, which we are all interested, is about the traffic management. I think you got a good insights about that. And the next part which I want to touch upon is security, right? Security is always is not a concern for the developer's perspective, right? So we all think somebody else's responsibility is security, right? So with respect to security, the enabling secure communication between microservices, is there something which we could leverage from Service Mesh? Augustine, do you want to share some insights around that?
Yeah, I mean, that's a great point. If you see most of the service meshes that are based on Kubernetes, which itself in turn is based on a sidecar proxy pattern, right? And if you look, most of these service meshes also kind of piggyback right on those. Now, what is the good part of that? So at least the developer can just, focus on his application, his business logic, and that gets done. And all the security aspect is offloaded to the sidecar. Now, one important aspect of anything of security, if it's exposed or is unencrypted, that means it's an option or an avenue for malicious access to that. Now, this is where most of the service meshes, are trying to either implement or like trying to bring into the incremental mutual TLS. That means each part of the client server, whatever different parts of the stack are all talking to each other, but in an encrypted manner. But that means you'll have to have a rotation of certificates. Now, if you have ever been into certificate management, this is a lot of problems. You have to take care of a lot of things, right? And this is where a lot of issues will come, because you miss the little thing, the bad actor will find it. Because that's what his job is, right? He just to find one little small loophole and he will just ram through and get through that. Now, this is where most of the service meshes, they take that onus on themselves. So they do all the certificate rotation, the expiry of that, look into it, send the certificates to the different nodes and or whatever different artifacts are there within that cluster, and they take care of it. The second aspect is, do you have the access to a particular resource, right, or to a service, right, in terms of service meshes? And that's where role-based access control comes into play, right? So you can have this finely tuned access to a particular service based on, the pathway or whatever you did. That means we are now working on a basis of what? Zero trust and least access privilege. So that means now I'm clamping down on any other further avenue of, people trying to maliciously enter or inadvertently do something which they're not authorized to do. So we got that aspect here. Now, the fourth one, that the most important, is testing, observability, and these other things. And that's a very good segue for Ilyas to come into, and talk about this, because that's a very crucial aspect of any of this thing.
Yeah, absolutely. I think building zero trust networks and the communication is one of the primary focus in bigger enterprises, if you're part of, right? I think it's good to know that the service mesh is able to bring the capability out of the box, and then we'll be able to not overload the developers with doing any extra activities, and then it's all offloaded to the service mesh. Yeah, it's a good lead, Augustine. Thank you. And the next part is about, I think you touched upon observability, right? So yeah, we've enabled the traffic and then we've made it secure. But how are we going to monitor all of these entire microservices, right? And how do we troubleshoot issues if something goes wrong in the world of 1,000 microservices or even 100 microservices? How are we going to identify it, right? So Ilyas, do you want to touch upon those?
Yeah, so before I start talking about the observability and monitoring capability of Istio, but I'd like to thank Augustine for highlighting the SSL and MTLS part, because the moment he talked about that, everybody started smiling, simply because every developer, right? Although it's getting every developer is now getting into full stack and getting some awareness about SSL from infra and everything, but it is still Greek and Latin for many developers. And hence, service mesh, taking care of MTLS as well as the overall SSL or TLS is it's a great benefit for the developers. Now, coming to the observability part, right now, everybody, all of us certainly agree that monolithic architecture is broken down into multiple tens or 15s or hundreds of microservices. Now, just imagine when there is an error. Error could be due to latency or traffic or whatever it may be, or application-specific error. It is always challenging. It is like finding a needle in the haystack, because you have so many services, so many APIs and front ends and back ends and so on. it would be very hard for anyone, be it developer or ops guy, to go figure out where exactly is the problem, right? So I was recently working for a customer where they have lots of nodes, multiple containers running, and all that they know is the latency when the number of requests per second, I mean, so and so second, the so and so number of requests goes to about, let's say, 10,000. The performance degrades about 2 seconds or something. So, but that's what we know. But other than that, we don't know which particular API or which particular method is causing the delay. Is it at the API layer or is it at the backend layer? So it was very challenging simply because there was no monitoring capability, or APM was implemented in that particular project. But this also highlights the importance of setting up a clear observability infrastructure for the application as well as the infrastructure, so that when something goes wrong, we'll be able to understand where exactly this is occurring. Is it at the application layer or somewhere else, right? So that's it is very important for the overall state of the application. And within the SRE arena, people talk about 4 golden rules about observability of any system, be it microservices or non-microservices based solution. Latency, traffic effectiveness, and then errors, as well as saturation, right? So for the same case, the database was overloading, but then they were not able to figure out that the database is running out of space. So now, since we are talking about microservices, in fact, all the top players in the microservices arena have got a very good observability tools and technologies in the belt, right? So if you talk about Istio or Linkerd, all of them are open source, and they have very tool chains integrated right in the platform. So the moment you turn on Istio or Linkerd for your solution, you're going to get dashboards that will give you a lot of visibility into how your stack is performing, right from ingress till the egress, how the calls was translated from one service to another service. If there is any error, it is going to pinpoint you. It is going to help you understand where exactly the error was introduced, or which particular service is taking more time compared to the other service, right? So there are a lot of benefits of utilizing service mesh, and more specifically these open source technology-based solution that could bring in a lot of visibility and transparency into the operation of the solutions.
Great, Julius. And I assume when you said all of these brings an out-of-the-box capability, that means the developers need not worry about injecting any specific components or DLLs or any kind of jars into their application, right? All this happens as a magic for them. They just need to focus on their own existing regular functional development aspects alone, right? I think
exactly.
if that's really a great benefit, right? So we don't, and again, going back to Karthik's point about polyglot, it really brings in great observability experience for us, right? Because building a common library targeting different languages is not as easy a thing, right? But if it's all happening at a layer on top of our on our application code, it's really good. And Elias, another question for, since you touched upon a couple of service mesh options. So can you also talk about what are the other options you experimented or explored, which are out there, which people can go and explore more also, right? I know you touched upon Istio and Linkerd. Are there any other popular open source service meshes?
There are plenty. So although this particular space is relatively new, so it's been about 5 to 6 years, but there are several players who are coming into the market. So apart from Istio and Linkerd, there are players like CON003 that's coming from HashiCorp, and AWS has their own app mesh, and Traffic. A popular proxy tool has their own service mesh, and Kuma. So a lot of them. So in fact, Microsoft has now come up with open source open service mesh, which is very similar to the rest of the open source mesh as well. Yeah, there are plenty. Okay. So it is also becoming a challenge to pick the right one. But then there are a lot of articles and researches about this area and comparing which particular service mesh has a lot of features. So it is even easier for us to pick the right one.
Yeah, right. Excellent. So I think, now we got a good hold of what are the capabilities of service mesh, right? Now, if someone wants to implement a service mesh in their infrastructure, what do they need to do? Is it applicable only for a brand new microservice based application, or can they also apply the service mesh on top of their existing workloads? So how do you go about doing it? Karthik, do you have any experience and insights around that?
Yeah. Okay, so with respect to service mesh, you can do it for a VM or it can be for a Kubernetes. It can be on both. Okay, so it is not something like you can something which is needs some special settings. The main point is I have explored certain parts of Istio, so I'll be very comfortable in explaining through Istio. That is what I was thinking about, but I'll still stick to service mesh account. But every service mesh almost works the same way. All you have to do is first, whether it's a VM or Kubernetes, you need to make sure you install the service mesh into that system. Say, let's take Kubernetes as an example to not have more confusion towards it. Let's take you can actually replace the word with VM also. So install your service mesh and make sure you take your okay. So before that, what we want me to let me explain the sidecar pattern. So okay, so why do we go for Istio? It's basically for some kind of cross-cutting mechanism you need to put, right? Like it might be an authentication, it can be some say monitoring, or it can be some kind of a TLS termination, whichever you want to do. So that is what you want to do, right? So what we can do is you have to figure out what that corresponding Istio, the service mesh is YAML files, and then you need to install that, and you have to enable it for your own pod. Meaning, say I have a pod, say orders pod or a product pod, I need to enable for that pod. Saying that it can be either a new system or it can be a old application which is existingly running in your system. Meaning, say I have say 50 pods or 50 microservices. So what I would suggest is you start with one service and then implement, say, authentication or logging to that, and see it works, how well it works, and then you keep on adding it to that. So you adding it to your YAML file, the existing pod is actually pretty easy than adding everything into one everything to every microservice, authentication to one authentication to every microservices. Add to one, see how it works. Yeah, make sure that logging is better. You can monitor it as you enable Grafana. So all those you can do that. Once it is fine, you do it 5, 10, and then later 20. So that is how we have to do it. So first thing is you have to install. You have to make sure that you enable your corresponding cross-cutting concern for your pods. Test the pod and enable more and more. So that is the best way of doing it. Back to you.
Okay, great. So you mean take a piecemeal approach. So just identify the capability, what you want to put, be traffic management or observability, identify it, and then apply it on one of your microservices or a couple of them to understand the traffic management aspects, and then you can incrementally progress from there. Yeah, that's a good call out, Karthik. So I know we talked about the service meshes are going to offload a lot of things about from the developers, right? So that means somebody else needs to really manage that entire service meshes also. So now what kind of challenges it could bring in? Augustine, do you want to talk about some of the challenges we might encounter, or what are some nuances people should be mindful of when they start working with these service meshes?
Yeah, I mean, the first question is, do you really require service mesh, right? I mean, that's the first question you need to pose yourself. Because the elephant in the room is that most of the service meshes actually installed on, like on Kubernetes, right? Which itself is a big beast in itself, right? You have, it's a huge thing, it's quite complex, a lot of running parts are running on it, and then you now add another layer on top of it, which itself is not small, it's quite complex and intrinsic, right? So while it hides a lot of complexity from you as a developer, if something goes wrong, you really have to have the engineering chops, right, to go and find this is an issue. So do you require, a whole a good grasp on networking concepts, as well as, monitoring tools that can pinpoint, okay, this is an error, this is where something can go wrong. Because with Kubernetes, with Docker containers, there's a lot of resiliency built in it. So by the time you know there's an issue, it could be quite late. And so your time frame to to solve, especially when there's a critical like financial loss kind of issues that you really want to pinpoint as soon as possible. You've got to be very well versed in the networking stack, because one thing about service mesh is really working on the layer 7 of the OSI, right? So there's those things that will aspect in terms of, okay, I had to look at the app level, the pathways and all. Also sometimes below the stack at the TCP level. So these awareness in terms of engineering, you have to be really careful. So there has to be a certain scale for you to adopt service mesh, and once you have that scale, you should have the engineering bandwidth, like to really finance and okay, solve that issues and that keep coming up. Because one aspect of it is, because of the network, speed is quite essential. Like if you look at all the proxy side proxy card, if you look at Envoy that built on C++, if you look at Linkerd, it actually re-architected this whole sidecar proxy from this erstwhile technology to rust because speed is of the essence. Because speed of the essence is anything goes wrong, you have to be really, really good at networking to find out the need.
Yeah, absolutely. I think that's a great input. Yeah, first identify whether you really need service mesh, considering your scale of microservices, and then see if we have the engineering bandwidth to handle the service mesh by itself, right? That's good input, Nagasan. I think we are almost coming to the conclusion of this session, considering the time what we have, right? I know service mesh is a very vast topic, and each of these capabilities can themselves be talked for multiple hours together, be it traffic management or observability or security. But yeah, so what we try to do in this session is just to wrap up. So we started with about the introduction to microservices. I hope you understood why you want to go with microservices. And then as you start scaling your microservices, what kind of problems you would get. And then we also touched upon what are the different capabilities of service mesh that could be applied to solve those business come technical problems, right? And also we touched upon some of the challenges or the operational nuances, what it also brings in for us. Yeah, I hope with that you would have got a good idea about what service mesh is, and then where does it fit in, and where to use it, where not to use it, how to use it, etc. So yeah, thank you so much, experts, for sharing your knowledge, and thank you so much, everyone, for joining this session. Stay home and stay safe.
Thank you.
Thank you. Thanks, everybody.
Thank you.